So, good morning everybody. I'm here to talk about the present and future of AI. But since AI is something which is very weird topic, it's so many things. People mean so many things with AI. I'm going to go backwards in time, 50 years. 50 years ago, people were enthusiastic about the developments of AI. Sounds familiar, right? They thought that any time now there is going to be revolution in robotics and AI. This is from Jetsons. There's Rosie the robot that can do everything that we would like AI to be able to do. People really thought that this is going to be reality in about 10 years' time. And they were afraid also that robots are going to take over. Robot revolution could be imminent. Of course, this wasn't the case. Scientists were trying to educate people. This is not really going to happen. At that time, computers only did what they were told to do. Nothing more, nothing less. So that's programming. We are all familiar with programming, and nowadays we wouldn't call that AI. Anybody can program something. But at that time, it was the first wave of AI. First types of AI were just that. Our society has been built on automation based on computers, so programming has helped us a lot. But there are clear limits to this kind of AI. There are many real-world problems that the AI cannot really solve. If you think, for instance, of vision problems, you take camera images and then you need to recognize something. Programming is not going to be enough. And that's why we now have machine learning. And the AI nowadays is based on learning from big data sets. Like in self-driving cars, you collect huge amounts of data and then you learn to recognize things. People are annotating data and so on, but that's reality. That's how it works. You can also use this kind of AI to transcribe speech to text. So it powers virtual assistants and other gadgets. My phone understands my speech. It's based on modern, today's data-based AI. Machine translation. That's also one example where this kind of deep learning-based AI beats programmed techniques. So today, we could say that computers only do what they learn from the data. It's all about big data. We still don't have the Rosie the robot, do we? And 50 years ago, if you looked at how the AI was performing, it's easy to say that imminent robot revolution wasn't really a threat. Here's an example of an industrial robot doing its job way back. And you can see that it's just repeating its program. If something unexpected happens, it's completely at loss. Now, today, AI learns from data. But if you look at modern robots, what they do, trying to open that valve and finding themselves in an unexpected situation, they're not doing much better, are they? So robotic revolution is still not imminent if you look at AI of today. We humans, we can do much better. We obviously have something that AI nowadays doesn't. So let's have a look at human cognition. Let's have a look at what's powering human brain. I'm going to take an example Homo sapiens in its daily life. I'm going to use myself as an example. I bike to work every day. I take exactly the same route. So every day I turn right in this cross section or this junction. Some time ago, we had visitors coming in, and I was supposed to go and buy the ingredients for dinner. And the grocery stores are right in front, so I'm supposed to drive straight ahead. I was thinking about my presentations or something, and you guess what I did? Did I go straight? No. I turned right. That's an example of this automatic mode of cognition. There are different types of cognition, different modes of cognition. If some of you have read Daniel Kahneman's book, Thinking, Fast and Slow, you know what I'm talking about. There's this mode of cognition which Kahneman called System 1. It's the autopilot. It's the automatic reflexes and learned behaviors that take me to home. It's the default behavior. It makes me turn right. It's unconscious. I don't know how it works. I just do it. I don't have to think about it. It's completely automatic. It's also very crystallized. If there's a new situation, like now I have to cook dinner, I'm not able to change my behavior. The best thing about this System 1, though, is that it's really fast. That's the kind of cognition that helps us when a car is trying to hit us, or maybe way back, lion was trying to eat us. Biking would be impossible without this kind of cognition. There's another type of cognition, System 2. They are happening at the same time always. So when I was biking, my System 2 was engaged in thinking about something else. It's the exception handling mode of cognition. It's slow and it's conscious. I can tell you what I was thinking. And I remember I was thinking about my presentation. I was thinking about this very same slides for my TEDx Helsinki University talk. I was planning, so there was something going on in my mind. Real cognition is System 2 cognition. The kind of AI that we think that we should have System 2. The best thing about this kind of cognition is very fluid. If you get new situations, System 2 is able to solve them. So if you encounter something the first time, you will most probably engage your System 2. And what I would like to argue is that modern AI, this machine learning based AI, big data AI, is System 1 AI. That's what we built. We take huge amounts of data and then we crystallize that knowledge into some deep neural network or other machine learning systems. This kind of AI is really good if you do have huge amounts of data. Google, Amazon, Facebook, these kinds of companies have really benefited from this kind of AI. So speech to text, that's clearly a problem where you want to apply System 1 AI. It's perfect for that. Recommendation engines, they can take inputs from millions of user interactions and learn what the users will do and base their recommendations on that. Image recognition, that's clearly an example where you do want to apply System 1 AI. We have very advanced tools for System 1 AI, and that's why people are thinking that if you have a problem, you should probably apply these tools. So people are trying to apply System 1 AI tools for problems where it's not the best thing. You try to change your business to resemble the business of large consumer companies like Google and Amazon and so on. If your business is, for instance, process control, this is not what you can do. You cannot become customer service for all kinds of processes. No, you have that process and you need to know how to turn the knobs. If you have some documents in your company and you need to extract the data, you might not have millions and millions of those documents, but you still need to extract the information. So what do? There are many real-world problems where people are trying to apply System 1 AI these days, big data solutions. So you start by collecting a big data lake. That's what you're supposed to do so that you look like Google. What we are now developing, what we are now already piloting is this new type of AI, which implements System 2 mode of cognition. And that's perfect for solving problems where the world is changing and you don't necessarily have that much data. You might have interactions with people and so on. I'm going to try to explain you how this System 2 AI works, what's different from System 1 AI. So, whereas System 1 AI is based on imitating behavior that you see in huge amounts of data, System 2 AI is more about learning to understand how the world works. What are the dynamics? What are the rules of the game? So you do use data, you can use data, you can also use some human programming if you want. Nowadays all system AIs are pretty much hand-programmed. So the internal simulations that are needed, they are hand-programmed. But you can also learn that from data. And then when you have a model of the process, then you can apply reasoning, so planning or analysis where you're trying to find the root causes and so on. You use that internal simulation to come up with decisions and analysis. It has been so far impossible to combine learned models with this kind of reasoning. So sure, you can learn all kinds of predictive models, but then when you have tried to apply planning and reasoning, the models have failed. The recent breakthrough that we have made, and others have been working on similar things, is that now we can actually learn these internal models from data and then apply planning and reasoning. And that's really powerful technique. I'm going to show you a few examples from real world. This is a case done by us and Neste Engineering Solutions. So actually, Juri Lindholm is somewhere in the audience. You can probably get a customer testimony after this if Juri is willing. Neste, I assume you all know, it's world leader in aviation biofuels, for instance. So it's a big oil refining company, and Neste Engineering Solutions is doing control engineering software, so NAPCON software suite is what Neste Engineering Solutions is developing. And we are now co-developing this thing as an AI co-worker for operators. So imagine an operator of this industrial process, oil refining, for instance. The operator is seeing hundreds and hundreds, even thousands of different sensory inputs. They need to monitor them, try to figure out what's going on. And then they have a lot of different knobs to tune, different valves and pumps and so on. It's a difficult case, right? So now imagine, how would System 1 AI solution look like? What you would do is you would collect huge amounts of data from this operation. You see what the operator does in different situations. And then you can build an AI coworker that gives these suggestions. Tells that, okay, this is what you were usually doing when this similar situation came up. So it's exactly the same kind of mode as you have like Other users who bought the same books also bought this. Same kind of idea. But that's very difficult to implement in the real world because the system keeps changing. There are things that happen for the first time. What do you do then? So a system 2 approach is not to learn directly the actions that are supposed to be done, but try to learn a predictive model of the underlying process. If we do this, that's what's going to happen. That's not a recommendation for what to do. But if you apply planning and reasoning, then you can figure out what are the actions that you should take in order to reach desired goal states. Optimize production, maximize the profits, minimize energy consumption, whatever. So no matter which goal you have, the system will be able to figure out what to do. And because these rules of the game, how the process works, is fundamentally simpler than the recipe for controlling the system optimally in different cases, you need much less data to learn this. So we only need a few days of operation data to reach human behavior or even go beyond that. That's very different from System 1 AI. Now, this is a very general system. You just learn how the underlying process works, and then you figure out what to do, using reasoning and planning and so on. So, System 2 AI is really nice for decision making. The principle is that you learn an internal model, and then you plan. It's really sample efficient because it's so much easier to learn the dynamics than it is to learn the optimal policy or what to do. Similar thing, like it's very easy to learn what are the rules of game, like chess, but it's much more difficult to learn what to do in every different board position. So once you understand how the system works and you apply planning, then you can get away with much less data simply because the system is so much simpler. Transparency of these decisions is very important. We can ask the system why it did this, and it can say that I did this because I think that's what's going to happen. And then we can ask, for instance, okay, why didn't you do that? And then it can say that, well, I think that in that case, that's what's going to happen, and I think that's worse. So there is a way to explain the decisions. And this is very different from modern System 1 AI. They are black boxes, and they just do stuff, and they can't explain why they're doing. But the System 2 AI can also explain its decisions. So these properties make it really nice fit for real-world problems, like for Neste Engineering Solutions or for Sandvik. We are also now working with Kone to build elevator control or test elevator control with this technology. So it also works for logistics and other things. Now I've talked about control cases, decision-making cases, but the same underlying principle also works for analysis. System 1 AI recipe for analysis is collect a lot of data about inputs and correct outputs, and then just learn to imitate. System 2 recipe is like try to understand the underlying principles, underlying rules or constraints that your domain has. Like for instance, we've implemented invoice automation with this technology for Berggren. And in that case, you need to just learn and code also. And some of these things you can just tell the system. For instance, numbers add up in invoices. And that's something that you don't need to learn from data. There are other things that you can learn from data. Once you've learned these principles, you find the optimal explanation by search. So it's the same thing as what you are doing in planning. You're applying some kind of search algorithm to find the best match. And because the underlying principles of accounting are so much simpler than the recipe for extracting the correct information in every different situation. It's very data efficient and it generalizes really well. So our researchers tried what happens if you take receipts. This system had never seen receipts, but on the first trial, it already was able to extract the correct information from this receipt because the underlying principles are the same as in invoices. You have some numbers and then they add up to the total sum. You have maybe some tax percentages and so on. The same underlying structure, which means that it just knew how to do it without any further training. So really, really nice generalization. So my claim is that in the future, we will have AI that combines both System 1 and System 2. Now we have very nice tools for System 1, and they can do amazing things. Their best property is that they are very fast to operate. Once you've trained the system with huge amount of data and compute, after that it works really fast. But there are many problems with it. You need a lot of data and compute. It cannot invent anything new. It's a black box. You can't explain it. System 2 has exactly the opposite properties. So they complement each other very well. The only drawback of System 2, I would say, is that during runtime it takes more time. But then we can use System 1 AI to speed up the thinking process. So it's efficient in learning time. You don't need much data, you don't need much compute. And it can solve new situations. When you run up into new problems, you can combine your information from previous solutions and come up with new ones. And it's transparent. It can explain its decisions. So this combination is what I think the AI of the future will look like. Thank you.